Bayes' theorem. Partition of sample space. The set of events E1, E2 up to En is said to represent a partition of sample space S if EI intersection EJ is equal to null set I not equals to J, I, J is equal to 1, 2 up to N. E union E2 union up to En is equal to S, and probability of event EI greater than 0 for all I is equal to 1, 2, 3 up to N. Theorem of total probability. Let E1, E2 up to En be a partition of the sample space S, and suppose that each of the events E1, E2 up to En has non-zero probability of occurrence. Let A be any event associated with S. Then, probability of event A is equal to summation from Bayes' theorem. Bayes' theorem. If E1, E2, E3 up to En are n mutually exclusive and exhaustive events associated with a random experiment, and if A is any arbitrary event which occurs with E1 or E2 or up to En, and probability of event A not equals to 0, then the conditional probability of occurrence of EI for I is equal to 1, 2 up to N, given that A has already occurred, is given by conditional probability of EI when A is given is equal to probability of event EI into conditional probability of A when EI is given divided by summation from J is equal to 1 to N of probability of event EJ into conditional probability of A when EJ is given for any I is equal to 1, 2, 3 up to N. Important points. The probabilities of E1, E2 up to En are known as prior probabilities because they exist before we have any information about the experiment that will occur. The conditional probability of A when EI is given, I is equal to 1, 2 up to N, are called likelihoods because they indicates how likely the event A under consideration is to occur, given each and every prior probability. The conditional probability of EI when A is given, I is equal to 1, 2 up to N, are called posterior probabilities because they are determined after the results of the experiments are known.